We will do the last two questions. I'm taking up question number 4 and question number 8. Question number 4 is one of the most important questions in factorization. Okay, let's see. We have this formula right here. This is a question number 4 of your exercise 3.1. Look what the question is saying. We have got a cube plus b cube plus c cube is equal to thrice abc. We have to prove a plus b plus c equal to 0, or a is equal to b is equal to c. So before we answer this, before we try to obtain the solution for this, first of all, we need to know two concepts that you have already learned. I'm just reminding it to you all. First concept is, you note this down, okay? If AB is equal to 0, if A into B is equal to 0, we will have either A equal to 0 or B is equal to 0. Or we will have both A and B is equal to 0. Okay, let me explain. If two numbers are multiplying, two numbers A and B are multiplying, we don't know what values of A and B are. If A and B are multiplying and we obtain the value as 0, the condition will be one of them will be 0 or both of them will be 0. Okay, let me give examples. 2 into 0 is 0. 0 into 3 is 0. 0 into 0 is 0. In order to obtain the multiplication is 0, one of them has to be 0. In these two situations, one of them is 0, right? In the last one, both of them are 0. Okay, only and only that way we will obtain the product of two numbers to be 0. So you copy this. We have already used this in quadratic equation on the videos that it is uploaded in the YouTube. You will be seeing when A into B is equal to 0, you know either A is equal to 0, B is equal to 0. We have already used this concept. Okay, and then one more thing. Second one, what's the factorization for this? For this, the factorization look like this: A plus B plus C. And remember, we just did it yesterday. There is a half in the front, and we have got A minus B whole square, B minus C whole square, C minus A whole square. So this was the factorization that we have obtained. You can look it up if you want to understand how we have obtained this. So no need to copy this. We have already done this. But this is a concept out of this chapter. So you just keep it as note on the side. Okay, now I'm rubbing this off. I'm just keeping this portion on the side so that you will have time to copy. I'm just keeping it on the side. Right down here. Yeah, you copy this while I'm teaching this, okay? Okay, now look at this. What is given? When we come to the solution, the given part is A cube plus B cube plus C cube is equal to 3ABC. I'm bringing the 3ABC on the left hand side. Let's see what we obtain. A cube plus B cube plus C cube minus 3ABC. This is equal to how much? This is equal to 0. So remember the factorization for this. I just wrote it down here, right? What did we obtain? Half A plus B plus C whole bracket A minus B whole square plus B minus C whole square plus C minus A whole square. Let's write this down. So instead of writing this whole expression right here, we will write the formula: half A plus B plus C A minus B whole square, B minus C whole square, C minus A whole square is equal to 0. Okay, let it stay there for a while. I'm going to teach you one more concept. This part is done, yes? Has everyone copied this? Answer once. Yes or no? This portion. Okay, anyway, I'm removing this, okay? And let it freeze there. Let me teach you one more extra concept. If A square plus B square is equal to 0. When you add two numbers, if I add A and B is equal to 0, the conditions are: if A is minus 3, B is of the opposite sign. How much is it? We obtain 0. If I have 3 of them, the values of A, B, and C, I can arrange them like this. -1, +3, -2. How much is the total? Look, -1 and -2, we will obtain -3. -3 and +3, we will obtain 0. So when we add 3 numbers, none of the signs are similar. The signs are different, at least for the 2 of them, right? Or simply if we consider just 2 numbers, forget the 3 numbers. If we consider only 2 numbers and when we add them, if the sum is 0, A plus B is equal to 0. What's the condition? If sum is equal to 0. Then if I take one of the number as 4, the other number will be -4. So that their sum will be how much? 0. If I take 10 here, the other one will be -10. If I take this as -12, the other number will be +12. Look, the signs are opposite, isn't it? Or another possibility is if A is 0 and B is 0. 0 plus 0 will be equal to 0. So in order to arrive at the addition of 2 numbers is 0, we need 2 conditions. First condition is A is equal to -B. That means they are opposite sign. Second condition is both of them are equal to 0. Okay. But look at this condition right here. If A square plus B square is equal to 0, A square plus B square is equal to 0. There is no possibility that A square will be positive, A square will be negative. This cannot be negative. Why? Because there is a square here. So let's say I have -2. -2 square will be how much? -2 into -2, so we will have +4. We are getting a plus sign, right? So whenever you see a negative, whenever you see a square number, you should always assume that this is a positive value. What about B square? There is a square here also, so that means this must be positive. Addition of 2 positive number is 0. How is that possible? Can I add +1 and +1 and then obtain 0? No. Can I add +2 and -2 and +2 and obtain 0? Yes. But in that case, the signs are different. Signs are different. But in this case, when we have A square and B square, A square is positive sign, B square is also positive sign. That means there is no possibility that this is one number and this is another number. And we obtain the sum as 0. So the only possible condition here is A is 0 and B is also 0. That way 0 square plus 0 square will be equal to 0. Very simple. So if you encounter such a situation, if the addition of 2 square number is equal to 0, if it is any other number, then we will have some other value of A and B. But if the addition of 2 square number is 0, you should know that both of them are 0. If the addition of 3 square number is 0, forget cube, okay? If the addition of 3 square number is 0, then we will have A will be 0, B will be 0, C will be 0. If you have 4 of them, don't have cube there, okay? If there is 4 of them also, if the addition of these 4 square numbers is 0, then we will have A is 0, B will be 0, C will be 0, D will be 0. Okay, so you copy this condition also. If A square plus B square is equal to 0, then A is equal to 0 and B is equal to 0. Before you copy this actual question, you don't need to copy the question. You just say exercise 3.1 question number 4. For that convenience, I'm writing the exercise and question here. We are not changing it. So by abiding on these 2 conditions that I just gave, what was the first one that I gave? The first one was if A into B equal to 0, A equal to 0 or B is equal to 0. Okay, let's see. Look at this whole question right here. Let's come back to the question itself. We have 2 factors multiplying. Multiplication of these 2 factors is equal to how much? 0. So this is this condition right here. Instead of A right here, we are having what? A plus B plus C. Instead of B right here, we are having this whole expression right here. So If this condition is there, we know that a is equal to 0, right? So, but instead of a, we have a plus b plus c. Based on this condition, so what are we going to write? Now, a plus b plus c, this is equal to 0. Or the other one will be equal to 0. This part will be equal to 0. This part is what we want to obtain in the equation, this part right here. So we have proven the first part, right? The first part is proven. What about the second part? We want to prove A is equal to B is equal to C. Okay, look. Because of this condition that we have obtained, you know how we are obtaining this condition, right? Because of this condition, we have obtained the second property kicks in. What does the second property say? If you add two square numbers or three square numbers, all of them are equal to 0. Do we have any square numbers here? Yes. This portion, this portion, this portion, they cannot be negative. They're all positive. But why positive? Because there is square, square, square in there. If I add the square numbers, what are we obtaining? We are obtaining 0. That means this portion must be equal to 0. This portion must also be equal to 0. This portion must also be equal to 0. Okay, make them equal to 0 then. Make them equal to 0. So we will have a minus b whole square. It should be equal to 0. And b minus c whole square, this must be equal to 0. C minus a whole square, this must be equal to 0. If I want to remove the square will go to the other side and will become square root, right? But if you take square root of 0, you will still get 0. So if I remove the square, there will be no change here. So from here, we will obtain a minus b is equal to 0. Take the b to the other side. Now we are going to obtain a is equal to b. What about from here? Take the square to the other side, it will become square root. So square root of 0 is still 0, similar to the previous one. Remove the square, so we are going to obtain b minus c is equal to 0, implies that b is equal to c. You should take the c to the right hand side. Focus on the last one. Square is taken to the other side, becomes square root. And then square root of 0 is 0, so we will have c minus a is equal to 0. Take the a to the other side, we will finally obtain c is equal to a. What you need to understand is how do we obtain this? That's the key of this equation, okay? How do we obtain this? Is because of this property right here. If the sum of square number is 0, the number themselves are 0. So when you add the square numbers, we obtain 0. That means all of them must be equal to 0. Now, I can combine this 1, 2, 3. A is equal to B. B is in turn equal to C. C is in turn equal to A, right? But we can remove the last portion right here. Cut it off. What do we get finally? We get A is equal to B is equal to C, which is the second property that the question wants us to prove, isn't it? So I'm removing this. Finally, what we are getting is A is equal to B is equal to C from right here. Okay, so the first property is proven. Second property, the question wants us to prove, is also proven. So you just say here, hence prove. I'm moving on to the next question. Next question, remember, those who haven't attended the first class, let me just remind you type of factorization that we have done. We have done a factorization of this type. No, sorry. We have already done a factorization of this type. It should not be 3xyz, it's 3abc. How do we do the factorization? Remember, you just have to multiply all the factors by opening the bracket. We obtain ab square. Should not be bc, b plus c also. Made a lot of mistakes today. This is a plus b. So for this type of factorization, what we are supposed to do is you just multiply by opening the first brackets. You multiply like this, distributive property. Then you have to break down the 3abc into three parts, abc, abc, abc. So that way we are able to obtain ab square, A square B plus AB square, B square C plus BC square, CA square plus C square A plus, I'm breaking down the 3 ABC into ABC, ABC, ABC. Then we put each of this part in between here, one here, one here, one here. And then what we obtained was A square B plus AB square plus ABC. I'm putting them inside bracket. B square C plus BC square plus ABC. C square A plus CA square plus ABC. Then we take common factor from all these three. We take AB common factor from the first bracket, this bracket right here. We take AB, BC from here, CA from here, plus B plus C remaining. You can check it later also. I'm just doing it a little bit faster. B plus C plus A. Okay, so A plus B plus C, this is also A plus B plus C if you rearrange them. This is also A plus B plus C if you rearrange them. So I can take out these three of them as common factor. For this remaining, we will keep it later, A, B, B, C, and C. So this big expression right here, it's reduced into two factors, A plus B plus C and A, B, B, C, C. This is no different. This expression right here is no different than this expression right here. The only difference is instead of A and B here, we have got X and Y here. In the expression as given in the question, we have got X and Y instead of A and B. So if I shorten this, if I factorize this, we are going to get this expression right here, the final expression. I'm going to rub this off. If I factorize this part, I'm going to get an expression like this, except A will be replaced with X, B will be replaced with Y, C will be replaced with Z. So what does this expression is going to look like? This XY, X plus Y, plus YZ, Y plus Z, plus ZX, Z plus X, plus 3XYZ. This expression is going to look like this, except A will be X, B will be Y, C will be Z. So you copy the expression, we are going to get X plus Y plus Z, XY, YZ, ZX. Right. Okay. So this is just the introduction part. Let's come into the question. You read the question properly. You don't do it just by looking at it. It looks like that question. I will just do the solution. Don't do like. Okay, you read the question properly. What's the question saying? Look, find the value of this part right here. You have to find the value. What is given is X is given as this much, Y is given as this much, Z is given as this much. Very easy thing that we can do is, first of all, what is the value that we want to find out of? We want to find out the value of this one. We write this here, we factorize it, we factorize and obtain this expression right here. So you start saying solution. After factorization, this part is reduced to this. Now we will calculate this portion right here, because the value of X is given like this, Y is given like this, Z is given like this. Let's see, let's calculate X plus Y plus Z. Remember, we are calculating this value only, okay? We are not calculating this part. X plus Y plus Z is how much? Instead of X, we will put A, B minus C. Instead of Y, we are going to put B, C minus A. Instead of Z, we are going to put C, A minus B. So let's open the bracket, see if we are able to obtain any value. If you open the bracket, we are going to get AB minus CA. Then the other one is BC minus AB. AB is AB. AC, I can put AC, but I don't want to. I want to write it as CA. B and C is BC right here. B and A, it's BA, but I don't want to write BA. I want to write AB. Do the same here. C, A, and C, we don't write C, we just write BC. Can I cancel any of the term? Yes, actually all of them. Why? We have got AB here and minus AB here. They are opposite signs, isn't it? Minus CA and plus CA, they are opposite signs also. Plus BC and minus BC, they are opposite signs again. So after cancelling out all of them, we obtain how much? Since all of them are cancelled out, that means subtracted. The final value that we are able to obtain is 0. So what to do? Let's put this as equation number 1. So by equation 1, look, instead of this x plus y plus z, what value do we obtain? We obtain 0. So if I replace this whole value with 0, 0 into xy plus yz plus zx. What's the final value? If you multiply anything with 0, we are supposed to obtain 0, right? So we are obtaining 0. So by equation 1, the final value for xy, y plus z, sorry, x plus y plus yz, y plus z plus zx, z plus x plus 3xyz. The final value is going to be, instead of this, we are going to put 0 right here. This part, it will remain. So what's the final value? 0 multiply with anything is 0. Question 1 is to find out the value of this portion right here. We have found it out. What did we obtain? We obtain 0. Okay, so it's a very easy one. The only trick is you have to factorize this. You have to actually remember the formula. Okay, you have to remember the formula. You have to know how do we obtain this. So for convenience in revision, you just write here. What formula do we use? Using AB, A plus B, BC, B plus C, CA, C plus A, plus 3ABC. The value of this is equal to A plus B plus C, AB plus BC plus C. The only change we made is we made A, B, C into X, Y, Z. Okay, so I'm rubbing this. So your factorization chapter is essentially done here. The other questions don't need to do mostly. You can practice it. You can do practice question. You can take up some of the question and practice it yourself if you are able to do factorization or not. So if we recap, what we have learned is we have done 6 factorization. The 6 factorization, they are the standard one. They are called standard factorization. You have to understand all of them. Okay, you have to understand all of them. You should be able to do all of them. Remember, there is a 3 or 4, 2 or 3 or 4 mark that you can take for free from here. But you have to practice them. The 6 factorization that I've given, you have to practice them time and again because it keeps forgetting. And you have to understand the rules of factorization. I've also given rules of factorization, right? Rules of factorization, there is supposed to be a 3-step there. First step, second step, and third step. Remember what did we do in the first step? You have to multiply the terms and then expand the expression. In the second one, you have to arrange the terms in descending power of one of the letters. And then at last, you have to take common factor from all the terms. And then after you complete this first, second, third step, if the factorization is not complete, then you have to move on to the next letter and then do 1, 2, 3. So you just need to understand this, the 6 standard factorization and the rules of factorization, that's it. So for practice, I'm giving you some questions. You better do this as an assignment. Make it as an assignment. I'm just giving simple ones. I'm also going to give you hints on how to do them. You take up question number 2, Roman number 1 from your exercise 3.1. And Roman number 2, Roman number 3, and then you take up Roman number 5 also. So Roman number 1, you will be able to do it easily. You just look up factorization number 2. Okay, this one here, the hint for this is you have to use factorization number 2, factorization number 2, factorization number 2 that I've given. You just use it, use that formula. You have to look on the steps, how did we obtain that kind of factorization. And then this Roman number 2 and Roman number 3, we have just done it also. Roman number 3, I have just done it, but since it is not in your note, you try to do it once again. Roman number 3, it's the form like this. The ones that I have just done right now. Okay, so Roman number 3, it will be easy for you. Roman number 2, it should be your factorization number 1. I'm just writing it down here. It is factorization number 1. And Roman number 3 and 5, they will be similar. Okay. So 1, 2, 3, 5, you do it as an assignment for this chapter of factorization. Next chapter, we are going to take up trigonometry. Trigonometry, it's going to be a little long. It will be very interesting, but some of you may find it very difficult if you miss the class. Okay, so don't try to miss out the class, because trigonometry, if you continue to pursue any of the science subjects until graduation, trigonometry is absolutely essential. If you happen to take science in class 11, 12, in class 11, 12, the physics, most of it, it will have integration in there. If you happen to take not sorry, maths and physics, they will have trigonometry in there. So the foundation of it, we have to start learning in class 10. The introduction for trigonometry, we will have to do in class 10. Don't try to miss out any class.